Hello everyone, so we are live now, and in today's session we are going to solve today's Leetcode problem. You see, the problem is this shortest common super sequence, and quickly, those who are new to this channel, we solve live problems. This is a live problem solving session where I'll be solving today's Leetcode problem, and it is a first approach. Like, I haven't seen this problem before. You can see here it is not solved, and we will be building approach about how to solve this problem, and then we will be basically writing out the code. So the language which I use is C++, and it might be different from yours, but the core thing is to solve any core thing for any DSA problem is the logic. If we are able to figure out how we can solve this problem, we are well and good. Okay, so now let's go ahead and jump to the iPad screen where I have already created a notebook for today's session. So you can see I have taken a snapshot for this so that I can work upon it. Yeah. This is the problem, shortest common supersequence. Now, what is supersequence? I'm not aware of it at the first place. This is the shortest common supersequence, right? Let's read it. Given two strings str1 and str2. str1 and str2. Okay, these are the two strings we have been given. Return the shortest string both that has both str1 and str2 as subsequences. Shortest string that has both str1 and str2 as subsequences. So I know what a subsequence is. Basically, a subsequence means like if you remove some characters from a particular array or string, whatever that is left behind is the subsequence. So it means that the elements of these, in whatever order they should be there in the final string in the same order, but you can fill in some new numbers in it. That is absolutely fine. So we have to return the sorted string. So what I am sensing here is this. Basically, we have string 1, which will be like this, and we will have some string 2, which will be somewhat different, right? Whatever the answer string will be, this will be having these guys in the same sequence. There can be huge gaps between them, but the overall order should be same. Like this comes first, this comes before the second element, so that should be preserved. This comes before the third element, so that should be preserved in the order. We can fill in as much values we want between these particular checkpoints, right? So this is for str1 and this is for str2. str2 will be some other string probably, right? So let's say these two match, so it's better to have it there. And then for these we need to create, or we need to, like, we can just fill in here, so things like that. Okay, I see. So first of all, we should think of the logic, which is brute force. Yeah, so for the brute force approach, what I can see is this. Basically, I'll take string 1, and in the gaps of it I'll fill the another string, or vice versa. So we have some string 2 characters. Let's take an example. Yeah, ABAC and CAB. So let's say I took ABAC and we have CAB to be adjusted, right? So first I would like to see that what is the maximum amount of this string substring, this particular string, what is the maximum longest subsequence of this particular substring, this particular string is there in this string. The longest common subsequence of this string in this one. So it's a longest common subsequence or sequence. Let's say we found that there is some longest, this is the longest common part. So we have to return any valid string. Okay, we have to return them as well. So we find the longest common subsequence, and whatever that is left behind, what do I mean? Like, let's say we found out here that B is here, A is here, AB is here. We found out that AB is the most common part from this guy in this one. So we have to just adjust C. So we can put C here. Or if there are more characters, we can put C anywhere we wanted, right? And that could result to multiple answers. And that's the thing, guys. So the core logic is to find longest common sequence of str2 in str1. We have to chip in the rest values. Right, that's the logic which I have thought of at the first glance. Now here you see this is a very basic example where both of them are same up only. Now there are possibilities. Here in the problem we saw that ABAC was there and CAB was there. This part was common with this one. Now there might be the cases where we have example like, and we have something like AATFG. We have something like this. So in this case, this particular guy is common in this. So we need to chip in G in this region, and in this region we need to chip in F. Fair enough. Just for quick check, guys, I'll just check if we are actually live or not. Sometimes it has happened. I was actually live, but common in this. So we need to chip in G in. Yes, everything is absolutely fine. And let's resume our journey. So this is the logic which I have figured out. We have to find the maximum common guy which just exists in the particular thing. So if I bring the problem, so the problem one is to, now I'm going to the algorithms stage. In algorithm thing, the first thing first is this, right? Find longest subarray, let me call it substring of str2, which is there in str1. str1's sequence, rather subsequence. Yeah, the longest substring of str2 which is there in the str1's subsequence, right? So now if I talk about the number of so str, this is there. The second step is to chip in, I don't know if it's a good term to use, but I hope you got this. Basically, whatever is left, we have to insert in these places. Rest sections of str2 into str1. Now, if I talk about some opposite cases, like we can also do right this. Here we are chipping in str2 into str1, but we can also do the reverse of it. But for that, will it be same or will it be different? ABAC into AC. Okay, let's take an example. ABAC and AC. So if we work on this part, and if we work on this part, we found out that this particular part exists here. So we will chip in AB in this place. That makes sense to me, right? That makes sense to me. But there might be a problem. So why I'm looking for substring? I have to look for actually a subsequence. The longest subsequence which is common in the str2. Hmm. Why to look for contiguous stuff? We have to look for something which is like this only. So here we found AAD is common in this one, right? But there might be the case we got F here as well. In that case, we can say that AADF is sorted. Right, AADF. Let's say it was AADEF. GAADEF. So we found that this particular subsequence is already there in this one. Make sense? Now we have to chip in the values, right? So which we can just do directly. Otherwise we have to chip E and F separately. That will become a separate problem. So essentially it is about finding the longest. Yeah, it is finding about longest common subsequence of this and this. Let's say length of it is 7, length of it is 3. So we can have maximum 3 spots that are common in each of these. No, no, like let's say this is 3 here. So this will be common in some portion, like 2 is common in this. For 7, it might be possible that out of these 7, these 3 are common here. Or this 1 is common only there. That is not possible. So this is like a mutual relationship. So whether you check, so I think the approach which I am currently choosing is not good because the longest common substring is actually not a good solution, is actually a wrong solution. Why? Because we have just seen that if we find the subsequence which is common to longest subsequence which is common to this guy, that is also fine, right? That is actually better because if we just look for AAT here, let's say we had only looked for AAT which was common, we might have ended up injecting EF two characters, but we had to only inject E here. So I think this approach is wrong now. I have to change it. That was the first thought from the examples which I saw. And then when you cross question yourself, then you get to notice these cases. So this is the update, right? This is the update in the logic. Longest common subsequence of str1 and str2, mark them like which of these are common, and then prepend the rest. In order. So I'll just take an example. A, B, A, D, C, D, F, right? And we had G, A, D, E, F, right? So here we can say A, D, and F. A, D, and F is the longest common part. So what we will do is we need to insert this G and E somewhere. So yeah, we can just insert it here, insert it here. Something like this we can do. Like we can choose any one of these strings where we mark the common ones and we just chip in the rest, whatever the values we have. So by marking, what does that mean? That we should have idea about this is the common part. Coding wise, this is going to be difficult to be honest. Logic wise, we have almost cracked it, but this is not an easy problem itself. This is commonly a DP problem, which if I remember. The thing is, I cannot even recall like LCS and LIS. But let's go ahead and give it a blind try. Obviously, we are not afraid of this problem at all. Cool. So let me think of the brute force approach, right? So longest common subsequence of str1 into str2. So str1 we get around 2 to the power n subsequences because it's more like nc1 choosing 1, choosing 2 guys, choosing 3 guys, something like this. Yeah, making groups of 3, and it is in sequence. How can I say that it is in sequence? Because these combinatorics are like they don't take order into the consideration, so they won't give repeated results by just interchanging the numbers. Like they won't say 2 3 and 3 2 are different. So this is kind of good only. So we got 2 to the power n possible substrings for str1. So that we will check in str2 if they exist as a subsequence or not. And for that, we can go up to like order n for each check. So this is 2 to the power n. This is this approach for this is all of this we are doing it for the first step. So this is order n into 2 to the power n, which makes it order n into 2 to the power n. And we all know n is 1000 here. So if I say this will be in the order of pretty much used. Okay. So if I convert it, let's say it's a 2 to the power 10 to the power 100. This is like 10 to the power 3, 100, 10 to the power 3. Okay, so this is no way a good solution, right? So we have to optimize it. We have to optimize it. So this is basically we have to break the problem. When we apply DP, because I know this is a famous pattern in DP. If you study any course or any material, you'll be taught these type of problems: longest common subsequence and sequences, subsequences and like things like that. They are standard problems. You should know that, the way you know prefix sum and other things. Right now, at the moment, I don't recall it, but I'll obviously solve it, so I'll be recalling it. Okay, so let's go ahead and do that. So now we have to come up with an approach. So there are obviously two strings, out of which some of them are common, rest others are different. This is your str1, this is your str2. Now what we have to do is to basically check. What check? So we have to check how we can formulate this in TP form, right? So just a second. This is of order 10 to the power 3. Both of them as a subsequences. Both of them as subsequences, right? And we have to find the longest which is common. Right. So how about this? Mm. So for DP we need to decide what will be the levels. How can we cache it? First indication you get from is the size of the test cases. This is 10 to the power 3, so we must think of n square, which means two uh, checkpoints for each DP that makes it unique. So we have to define something like this. So this is like a cool DP revision for you all. So there will be two parameters here, I and j, and we have to think of a definition of DP which makes it able to cache, and that will return the things. Let's say we have this small section of strings, and if we have to return the answer of it. So the answer of so basically DP and recursion, how they work, you have to break the problem into independent small problems, and there must be an aggregator by which you aggregate the sums, aggregate the things which you have divided. Got it? So this is your let's say our problem is restricted to these two guys, right? So the problem is here, given this string and this string, find the common part of it. Okay, so I'll see that these two are different. Obviously, one is green and one is red. Uh, let's say, for example, we have some values like f here and g here. So in this case, that we say that the length of the string which is common is 0. So 0 is common in this case. So maybe we say that the empty part of the string is common here. Now let's say if we include this guy as well. So we got something like ZF as an answer for this. For this particular section, we got answer as ZF. Now we have ZF with us. Not everyone has ZF. but we have ZF at the moment, right? So this is ZF with us. Let's say a new guy enters here, and this guy is G itself. So in that case, whatever the things which we have created, we will check. This is clearly not the way we solve LIS. I think there's some different logic. It's into L to R ranges, I guess. But you know, if I define L to R for this, L to R for this will go into 10 to the power, whatever it is, like it is n, right? 10 to the power n4. 4n basically. So not 10 to the power, order n to the power 4 it will go. The computation, the overall computation, if we define L and R for both of these then. So what can be done here? How can I cache these things? Basically I'm not able to break the problem into smaller ones. So if this is a string, so um, this part of it, this part of it, what I was thinking in this direction because of L here and R here, like basically one in the levels will be with the index of this index and some this index, the combination of these two. So what could that be? That could be like this, basically the region beyond this and the region beyond this. If we sort them out and we come up with a string which is the answer, then if we try to include this guy, it's very easy to include it. Basically we have to just check if it's there already in the string str in the same way. So guys, this is ZF here. I think I need to take an example again. So I'll take this one, ABAC and CAB1. These are very basic examples, man. Cool, so we got AB common here. Let's say I include a D over here. So that we got that thing. Now if I try my approach here, so I'll start with D's and D's. I got a string which is D at the moment. Then I included C. So what I'll do here, I will run for these two folks, which is whatever we got here, D, we need to just work on this part. So C can be appended right here, CD is there. Now let's say we come to this part, B is also there, B is interacting with CD now. This is not DP, this is a greedy approach actually. So this is basically, this will make it B, C, D. So you see CD is intact and we also got BD here. Then we have A's and A's which will turn eventually make BA only. Then we have B and C which will become There comes the question, either BC or CB, because both of them are correct. But if I use CB, then it might benefit if there was a C here as well. Otherwise, I have to think. This is too much pain. I don't think this is the right approach. So basically, the definition of DP is not happening at this point. How we define DP? It is essentially about finding the longest common subsequences. How can I define DP? Do you guys have any idea? So we got no chat here. That's fine. So I rarely watch common subsequences. They rarely watch these videos, yeah. I think it's already been 30 minutes. I remember how longest common subsequence we used to do. Mm, right, this was there. For subsequence, we can jump from here to here. So let's say we started with this guy, we found its first occurrence here. And then found this guy was present here. And then we move to the next guy in this region to find it if it exists or not. So we have two options from this point. Whether we take this or we move to this guy or we move to this guy. So we have actually n options here. And the reason in this part gets smaller. Right. So let me think of this in a better way. So I'll say this is str1, this is str2. This guy was matched at this place. Both are A, let's say. Cool. So we are at 0th index here, and we find this guy at 0, 1, 2, second index there. So the problem now becomes in this region and in this region, find the next possible, find the similar thing, right? So these two guys are sorted. Now we have these two guys with us. So we can probably start with this guy and look into this one, or we can start with this guy and look into this one. So these two possibilities are there. So what will I do? If I look by this one, this will be a separate case that will be already covered when I do the next exploration with that guy. Cool, 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 and cool. So we are working on 0 and 2. So we got A and A set it up common to each other. Basically, this A is uh, the first occurrence of this character in this string and the first occurrence in this string. That is done. Now, if we get more A's, we will be looking in this region only. So by default, it becomes that thing. So this 0th index and 2th index. So we go ahead, keep doing all these things till the end. So basically, this is choosing the next element. In the first step, we chose this element, this cute little small guy. In the next, this is like one branch where we go with, let me call this A, B, D, E, F. So we started with A. We found its twin, whatever it is, first occurrence in the str1 at index 2, this was at index 0. So we got AA, which is basically 0 and 2 of that other string. Now from here we have to go with new branches. And the result was probably A. Yes. Now we have to go to new branches. So we can go to AB, we can go with AD. So basically now the problem gets cut down. For B we find the answer. So for B we will say like B is the first index in the first string, and let's say B appears here. 3, 4, 5. B appears here. So B, for B it will be 1 5, right? And for B it will be 1 5. What does that mean? Whatever we do in this region and in this region, that is beyond 5 and beyond 1 in those strings, and whatever we get the answer. So let's say we had B here, so this was basically increased with, the length was increased with 1, right? So the answer will be uh, what will return to this guy will be 1 plus whatever we got at the later stages. And at the end we can just save the substring which was common, right? Now how will this repeat? How will the caching work in this case basically? So I hope you got my point. For B we will look where it is in their string. Now the next step is with AD. So we choose AD as the next guy. So AD is the next guy here. Now we look for D in str1. If we could not find, return 0, because could not find, return 0, because this is the maybe return 1, right? Return 1 because D is there in the string, right? Return 1 or something like as a number. Why do we need number? I don't think we need number in this case. We can have so basically when if we cannot find D, so we are now with AD, so we just save AD somewhere, or check if whatever we are saving is the longest. If AD is the new longest, we save, overwrite that with AD, and when we come back we just remove D from it. That we can do. So this is the case. So at the end of it, now you see that these are independent problems. Whatever answer you get from B onwards, and from this B onwards, is independent of the problem which we are solving. Like this is a separate problem in itself. Get it? I get that. I get that. I get that. Now I have to clearly define TP, and so guys, I have cracked the logic. In the next page, I'll define the TP very clearly, and then there will be one more extra step. So first step is to define DP. We are defining DP here. So what I'm trying to do here is this. We have str1 and we have str2. Yeah, we can swap these things, that is fine. So we start with 0th index in str2. I'll call this 2 at the bottom, right? And we have a temporary string which is, and here this is the current. Wait, let me just fill in that with some values, okay? Then that will make more sense. Cool. So we'll start with first zeroth index in the str2. This is for str1, right? And this is the temporary string. So this I call here 2 because this is the second guy index. So what we will do at the first place, we are working with A. We'll work with each of these in the progressive manner. So now we are working with A, which is the zeroth index. We find its occurrence, the first occurrence in str1, which is, yeah, in this entire string we find that. So which is at this finding thing, bro. This can take order n. Let me think. First, let me think. Then we come up with any kind of logic. Right. So we find A and we found A at the first index of str1. And the string which we got as common is A. Now, this is the basic recursive function. What we will do inside it, now we have option for G, F, D, C. These are the four branches that open from here. Basically, we go Z next or what next. So this will result in AG, this will be AF, and this will be AD, this will be AC. So we will look for G in one in index 2 and beyond in str1. If we found yes, G is there. If no, then return AG. AG is the string which got common, which we got common. But no, G, we could not find G, then it will be just A only, right? A is the most common string which we have right now. Otherwise, it would be for G, yeah, otherwise, if it is there, yeah, since it is there in this case, we'll launch another recursion guy with index in the first one as this, like this is the first index, and there it is the last index, which is 0, 1, 2, 3, 4, 5, 6. 6 index, and we got AG at the moment. So you see, this way we can do this. And we can probably return strings as results. But what I'm afraid is the fact that this can go up to order n cube because of the checks which we are doing, because of the findings, because of the things which we need to find out. What do I mean by that is basically finding if G occurs in this part of substring is order n operation. So at each recursive endpoint, we have, even if we cache, so this will be the answer of 0 and 0, 1. This will be the answer of 1, 1. There is no aggregation at the moment, but the answers can be repetitive. When we start independently with G, all of this can repeat. Let's say there was a G over here as well. So, right, that's the case. It is always good to take the G which is the first G because yeah, it's Z from where we start. Right, so then lookup thing will go beyond and beyond. So yeah, this is an order n cube approach, man, because at each step, so like for A only, we had to do this is an order n approach. There are n approaches. And this particular lookup thing in this guy is maybe we can make a frequency map and we can optimize that to somewhat like order one checks, but this will be still order n. So each step is going to be order n. And in the worst case, we might end up computing all the indices, right? So it's like 0. I mean, this will go up to n, this will go up to n. N square into order n at each step, right? And then we have to go ahead and work upon this. So this will become n cube for sure. And then you have to like another order and approach to make the final answer. Stage and doesn't really matter. Right. So I think this is not a good solution, man, because we have to be strictly in the n square range because that's what makes it hard. Longest common super sequence. Mhm. This approach was good, but can it be optimized further? Yes, it can be. How? This will be anyway ordered n because of the next stages we got. Um, Possibly be there. I have to think, man. How can I optimize this further? So, is tier 1 is tier 2. Yeah, yeah, if we talk about that case, then we found A is common. For A, we find the first occurrence of A, right? That we do. And then we move to the next guys. So what I'm essentially doing here is that we find for A's match, then we define our state, that this is the ideal search location for other upcoming elements. So this is the ideal space for upcoming elements. Right, we do that. And then why don't we just give this guys a separate space? And then we start with G here, right? Then we start with G here. We look for G if G is there or not. So let me just think it in this way. I'll take the same example. I think I have to learn a lot of things about how to use these notebooks in a defined manner. Cool. So the example is B, A, D, C, D, F, G. A, G, F, D, C. What I was saying, so we have these two strings at the first place, right? So what I was saying that, so the way we started here, like we look for the first character, it might be there, it might not be there, but we found it here. So yay, that's a match. Now we broken this down into a different problem, which is this one, right? Now here we look for G and we found it here G. So we say again yay and stuff like that. We reported that AG is there in the whatever you say. AG is one of the answer for these two folks. AG is one of the answer. Then we move ahead with the next guy, which is sizes, bro, sizes. Then we go to the next guy. We're done with G. For G, we broken down this separate problem for G is there. This is a separate G's problem, right? So whatever is written from that end, we just append to this particular guy. Like let's see. Right. When we are done with this G, we have to go to AF. Likewise, if we could not find a match for A in this particular string, then we had to go to another string. And even if we found a match of this in the string, we have to go to this part as an independent thing to check if there is another unique thing which exists there or not. So the way we are moving is really weird. But I can say that this is the first occurrence of A, so 0, 1. Now, if there is an A in this particular region, somewhere here, and we are starting independently for that, so it's very well and good to use the first occurrence of that. So that I have cast, right? The first occurrence of A is that index. So it's good to choose that. If the space is not constricted, you choose that, and what can happen next is basically there can be common pathways. Let's say we come next to D, and for D we see that Okay, this D and this D has already been cached. Because of the first run, they have been cached. Because we have answers for them. So what I'm forming is an approach, right? B, A, D, C, D, F, G, and A, G, F, D, C. So these guys, and even F1. Then we have D here. Then we have C here. Then we have D here. This will also form a thing like this. So what I'm saying is that right. So where is the reuse? Are we going to exhaust like all the states? Are we going to compute all the states? That's the question. That actually depends on the occurrences. If there is a number like A, so for this we found it here. Now in this guy, for this A, we start with this guy. That's way. And if we start a new branch from here, for this guy we found this, but we could also go with this guy. Hmm. So instead of first occurrence, why don't I find the last? So guys, this is really a tough problem, and I believe I need to take some hints. I never do that. I solve the problems from the heart. So I will wait for a solution to strike my mind because it's too late for this live stream, and I'll resume from here at the later stage. So I'm being honest with me myself. So you need to trust me. Even if you don't trust, it doesn't matter to me, to be honest, because I could have checked hints right away, but I want to think more on this. And since I got some other work, I need to pause this for a bit. Okay, so this is part one of that live session. Part two will be after this, like maybe when I get time to resume this, and my subconscious mind might come up with some logic to tackle this down because currently I do have a solution which is order n cube. I have forgotten. Okay, so I can do this. Let me just show you this. I can do one thing. I can revise LCS, which is a standard thing to have. I hope I have covered in my DSA notes. I'm not sure about this, if it is there or not. So these are trees and stuff. I think it's from BST. This is 0 to BST. Yeah, it's this guy. So this is arrays, dynamic arrays, linked lists, queues, sorting algorithms, binary search, trees. Okay, so I think this is all about trees now. This is the other data structures. hmm Then we have graph. So we don't have TP here. Yeah, so I forgot LCS thing. Maybe I can check how LCS works. Yeah, I cannot get the idea. Let me just check here. LCS algorithm. Yeah, I'll remove this KCS in front of it. So what is the time complexity of it? It is, what do you mean? The time complexity is 2 to the power m, like 2 to the power 10 to the power 3. Okay, this is the recursive approach. Yeah, so this is using memoization, order m cross n time and order m cross n space. So this is the LCS algorithm. What they did was S1, S2 is there. Skip last character of S1, which becomes AXY. Skip last character of S2, which becomes this. Then they did this. Skip last character of S1 and S2. How do they combine this? Basically, they are shortening the things. This is order m into n, which is fine. So it uses DP, correct? Yeah, it is a. So what is the code of this? Okay, so they found that the subproblem has been calculated more than once. Obviously, here what they do is basically they define the boundaries, right? So parameter go from 0 to m and 0 to n. There are the two parameters because I was thinking of the similar way, but there were four parameters. Start of the string, end of the string, start of the string, end of the string. 2D array of size this. I cannot get it, man. Like they started with this is the m, this is the end, which is basically starting is like they are the last pointer of both of these strings. In one case they remove this t from there, and in one case they remove this x from there. So then they get into okay, got it. This is very clever, man. Let me show you how they do it basically. Then they change to basically they are okay, nice. Doing that will what will that do basically? Let me think of this. This will generate all possible combinations. And what will be the answer of these things? All of these combinations का answer होगा. The answer of each one of them will be divided into smaller problems. For sure. Since there are two branches, whatever the answer we get from this guy is basically whatever is the common in this guy. What is the difference at the top? We get an X embedded to it. Now this is not easy to understand as well. Let me just focus on this part, what they have done here. So if m is 0, n is 0, return 0. They are returning the length. Okay, first of all, this is length, which what they are talking about. And that's fine. Let's go ahead. M is 0, n is 0, return. Either of them is 0, return 0 because there is no common string which is possible, right? This is memoization step. Here we have the match. If the last character matches Then they move to the next step. Oh, if the last character matches, then they move to the next step. This is the main funda of it. So they saw that, okay, they saw that, what did they saw? If last character matches, they increase the length and they go to the LCS of another part. So what does that mean? If, man, who explains this like this? You have just mentioned the code. What is the core thing of DP? You haven't even talked about it. Let me check some other tutorials. This looks good. Let me read it. So guys, this is very informative session for all of us. The longest common subsequence LCS is defined as the longest subsequence that is common to all the given sequences. Consecutive positions with original subsequences. Right. Are not required to occupy consecutive positions within the original sequences. If S1 and I could not get this part. If S1 and S2 are the two given subsequences, then Z is the common subsequence of S1 and S2 if Z is a subsequence of both. Furthermore, Z must be strictly increasing sequence of indices of both S1 and S2. That's what a subsequence, a common subsequence is. In a strictly increasing sequence, the indices of the elements chosen from the original sequence must be in ascending order in Z. So if S1 is this, then ADP cannot be, obviously. That's a basic understanding which everyone has it. So they say BC is common because you see BC is in ascending order in this string, and here also it is in ascending order in this string. Then CDAC. CDAC is in ascending order here. Yes, C, D, A, and C. Forget any one of these A's, right? C, D, one of these A's, and C. And C, D, this A and C, right? Then we have DAC, last one which I'm doing. D, any one of these A and C, and here you see DAC. So let's take two subsequences. This is your X and this is your Y. The following steps are followed for finding the LCS. Create a table dimension n cross n into m cross n. This is a table dimension where n and m are length of x and y. The first row and the first column are filled with zeros. Okay. Yeah, basically they're doing one based indexing, I guess. Fill the each cell with following logic. If the character corresponding to the current row and current column are missing, yeah, if any of these boxes are missing, sorry, matching, then fill the current cell by adding 1 to the diagonal element. This is some hack they have prepared with. So let's say this character matches. This is basically 0th index here and this is the nth index here. Means the first index of this. Oh yeah, they have already said here. So this is A and this is A. CBDA. Yeah. So it matches, so they kept it 1. And here, if it matches again, else take the maximum value from the previous column and previous row element for the filling the correct. The point is, why are we doing this? That's the main point, right? Here we did not get anything. So this C was matching, so we reference the diagonal element. For here, we reference diagonal element and it became 2. This is the maximum in this particular cell. So for the non-matching values, they have just copied this 2 from the previous cell, right? Here it was, I think this they want to say here. Okay, maximum value from the previous column and previous row element for previous row element and entire column. Previous column and previous row element. Okay. So if it is not matching, then max of these two is 2. Then you want to. So let's say they have created this thing. But none of these explain why are this thing's working. Hmm. So this is LIS, right? They might have been explaining it with proper solution, yeah. So see this, here is the solution. First, for the problem, we are given an array with n numbers. The task is to find the longest strictly increasing subsequence in A. So there is only one string. Yeah, this is a different problem. And LCS is a different problem. So I think Striver has explained it. This is what how I started as well. We would want to try something that gives us the longest common sequence. First build the recursive solution and then do that. Cool. Then we are considering S1 from index 0 0 to S2. Yeah, so basically they use a one variable here, I and j. So I will mean that from 0 from start till ith index, and here j will mean that from start till jth index. So they start with, and that's the definition of DP. And yeah, this is important. That's what I was talking about. What is the meaning of this DP? The meaning is longest common subsequence of this region. I got it. They fixed 0 at the beginning, right? How I was doing is basically I was doing the same thing, man. I was doing the damn same thing. I was doing this thing, right? If I show you, this was my DP's definition, right? I had two indices here. So I defined 1 and 5. So that meant like 0 and 2. So which means that we are looking in this entire region and this we are looking in this entire region. But they are something different. I was matching things. They just took it bluntly. Explore all the possibilities. In the function f22, got this. There can be two possibilities if these ending things are equal. Yeah, in this case, this common element will represent a unit length, common subsequence. Yes, this common element will become a unit length. So we can say that we have found one character and we can shrink both strings by one. So this is a half explained logic. The other half which I got in my mind, that I explained to you, because he says that D and D match here. So we are sure that there is one the string which is common to both of these. D is one of it, but there could be more D's, right, which are common to these two things. But the thing is that we are moving from the back side, which means whatever the first occurrence of D you spot, that is the best choice. That is the best choice for the longest common substring, which you will notice in the upcoming fronts. So here is this S1 IND1 S. So if the matches, they did this 1 plus function of, they just shifted it. If it doesn't matches, in that case what they did was they did 0 plus max of these two guys. Okay. So there are two possibilities at each point. So they did like that. Max of these two, whatever they get. And then they return the maximum of the choices. And this is the DP, guys. So I got the idea of this LCS thing now. This was completely non-intuitional and I forgot that. So that is what like took so long for me to figure out. Let me plug in the charger. Okay. Okay, we got no visitors. Right, fine, no problem. Okay, cool. So I'll just go to the code section because I don't want to. Okay. Okay, we got no visitors. Yeah, I don't. I just want to go to the code section. I won't be using this code at all because this is returning the length only. What we need to do extra in this case is basically we need to use TP, which returns the strings. The DP which returns the strings itself, because what we have to return here is this, a string data type. Okay, so I haven't checked solution. This is basically a revision of LCS, right? So that's how LCS work. Now the real problem stands at its own position. We have to solve it from ground up. Basically, we have to apply this logic. And the way he writes it, it is really beautiful. ACDCET, ACCE. But this is the final picture, man. Nobody gets it at the first place. Once you solve the problem, you can obviously break it down to explain it in a way that people get it in more easier way. What I do is a light problem solving. It is not something which I have already studied a lot many times and I compile it in this form. Okay, so this is really good. I can modify this guy as well. Like this particular chart can be modified. They were equal, so he changed it to AC and CE. And if they are not equal, then he is doing that thing to dividing it into two steps. So what we need to do is basically we need to have a string variable which keeps a count of these things. And we just store the string that is common to these. right? And then we do what? Then we do another set of operations to inject stuff. The injection stuff is later portion. That is also fun. Okay, I should do it. Probably I should do it. But before that, I'll check some of my emails or stuff. Guys, this is really fun. Now I'll be jumping straight to the coding section. Okay, so I should move to the coding section now. Uh-huh. Are you ready? But I don't recommend this. First, you should be clear with the logic, then you jump to the coding section. Okay, guys, so here is a quick thing. This will be the part one of the live stream. Part two of the live stream will be a fresh approach where I'll be first summing up what LIS is or what LCS is, how LCS works, and then I'll be building this approach to solve this particular problem. So this is part zero of this problem. Part one of this problem will be there at the later stage. Okay, so I hope everyone got that, and we'll meet very soon. Okay, that is it for this video. The problem is not solved yet.